Okay, so today we're going to look at more absolute value equations, solving them that is, and we're going to look at some that are a little bit more complicated. So we have something like this. Okay, the absolute value of 9x plus 1 plus 2 equals 37. So how is that different from the one we did the ones we did the other day? Um, Remember, they looked more like this. And yeah, it's simpler. We didn't have anything added, anything else on that side of the equation, just the absolute value. And this one has absolute value of 9x plus 1 plus 2 equals 37. So in this situation, can we say that 9x plus 1 can be 37, or it could also be negative 37? Those would both make it true. And why not if we can't? Well, you see, the reason we could do that before was there was nothing else with it. And looking at this example, we would say, okay, whatever's in there, that could be 9, or it could be negative 9. But if we try that in the one we're looking at, we see it doesn't really quite make sense, because if we say, well, 9x plus 1 could be 37 or could be negative 37, we're ignoring that 2. Okay, when the absolute value is evaluated, 2 is added to it, and then that sum is what's 37. So it's not going to work. We can't do that. The sum of the absolute value, when you add 2 to it, that makes 37. So what can we do about that? Well, the key seems to be that absolute value has to be by itself on that side, and then it makes sense to break it into the two equations. But we can achieve that, right? So we say first we must isolate the absolute value. It has to be by itself, and we can do that in this case simply by subtracting 2 from both sides. So we do that, and we get the absolute value of 9x plus 1 equals 35. And now we're ready. Just like the ones we did the other day, 9x plus 1 equals 35, or 9x plus 1 equals negative 35. And then solve it from there. You get the two solutions, x equals 34/9 or x equals negative 1/4. Okay, so let's look at another one. So we have the square root of, we have the absolute value of negative 2n plus 8 divided by 3 equals 2. Well, our absolute value is not by itself, it's divided by 3. We want it to be by itself. We need to get rid of that 3. Since it's divided by 3, we multiply both sides by 3. So we're just following the rules of algebra, and if we do that, we will get an equivalent equation that has the same solution set as the one we start with. So we multiply both sides by 3, and it succeeds in getting the absolute value by itself, and that's this step right here. And so we split it into the two parts. Negative 2n plus 8 equals 6, or negative 2n plus 8 equals negative 6. Both will make that true. And since we followed the rules of algebra to get to here, if both make that true, then they'll also make this one up here true. And so we solve those two, and we get two solutions, n equals 1 or n equals 7. Okay, we'll just look at a couple more. Here we have example C. Negative 10 times absolute value of r minus 5 equals negative 120. And just a little reminder again, absolute value, in this case absolute value of r minus 5 must be by itself. It's not right now. We have it multiplied by negative 10. Divide both sides by negative 10. We get the absolute value of r minus 5 equals 12. That's the form that we want. Split it into the two parts, like we've done on several of them. R minus 5 equals 12, or r minus 5 equals negative 12. And solve both of those, you get 17 and 7. So we just have one more. Here we have 4 plus, absolute value of 8 plus 6 equals 22. We simply subtract the 4 from both sides first thing, right? So that the absolute value is isolated. Then we split it into these two parts right here. 8x plus 6 equals 18, or 8x plus 6 equals negative 18. Solve both of those, divide by both sides by 8. And we have one of those, just turns out 12/8, reduce the lowest term, and we get, change back, x equals 3 halves, or x equals negative 3. So, it's just one more step, and it's pretty straightforward. You just have to put it all together and do things at the proper time and make sure you've done the preparation to go on to that step. The key thing about these is that absolute value has to be isolated on one side of the equation without anything else added to it, subtracted, or multiplied by it, or you can't divide that absolute value by anything. It has to be completely by itself. Okay, so that's all for those. There are more complicated absolute values than those, but we're not going to do those right now. This is as complicated as we're gonna get for right now. So that's all. See you later.